The velocity of the what? Yeah. So let me try to find that one. Uh, all right. Is it the one that says if a ball is thrown straight into the air with a velocity of something, what is the max height? Okay. Okay. So let me zoom in. All right. If you could turn the background volume down a little bit. All right. So, Luis, you can stay. Um, if you want more of a review, you don't have to. If you've already completed the assignment and you're happy with your grade. But remember that it's due at midnight, so you can get a higher grade if you want. Just saying. And the more practice you do, the better you're gonna get at it. So what I would recommend is I would stay for this part, and then you can decide after that. Okay. So when it comes to doing a problem, when it when something is traveling vertically. So in this question here, if a ball is thrown straight into the air with a velocity of 14 meters per second, how long would it take to reach the maximum height? Okay. So when we go through these problems, the very first thing that we do is hey Frank, could you meet real quick? Thank you. The very first thing that we do is we read the problem and understand what's going on. So if a ball is thrown straight into the air with a velocity of 14 meters per second, how long would it take to reach the maximum height? So I'm throwing something into the air. The velocity that I start off with is 14 meters per second, and it's asking how long would it take to reach the maximum height. Cool. So what is it asking us to find? So it's asking how long would it take? So that would be the time, and that's going to be in units of seconds. Cool. So after we figure out what we need to find, we go through the problem and we figure out what is given to us. So I switch back to the problem. If a ball is thrown straight into the air with a velocity of 14 meters per second, so we have 14 meters per second, and then there's only two velocities that we have when we're dealing with kinematics. There's going to be the initial and the final. So in the problem, we're dealing with a ball that's being thrown into the air, and we're trying to figure out how long it takes to reach the maximum height. So one of the criteria that makes something the maximum height is the instant that the velocity goes from positive, so it's traveling upwards, which is what we call positive. But as soon as it leaves my hand, it's going to start slowing down. And the instant that it stops going up, we're going to call that the maximum height. So my velocity is positive, but it's decreasing, 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 and then it stops, or it's zero, and then it becomes negative. And as it starts falling, it starts getting faster and faster and faster. The magnitude is getting bigger, but it's getting more and more negative as it's going down. So my final velocity would be zero, because that's the point where it's at its maximum height. That's my final condition, my final state. So the 14 meters per second would therefore be my initial velocity. So v sub I is 14 meters per second. And we just discussed that v final is 0 meters per second. Is there any confusion so far? I'll take the silence as everybody's okay. All right. Now in the problem, I also, in asterisks, I say, remember that the acceleration due to gravity, little g, is negative 10 meters per second squared. Now again, the negative 10 is in my class just to make the math easy. So that's a constant. Okay, so anytime that we're dealing with something that's flying into the air and coming back down, or just traveling upwards or free falling, in any of those kind of situations, acceleration due to gravity is always present. So that is a constant. So that is something that we can use in our equations. So little g is the acceleration due to gravity. So a little side note, that is an acceleration. Okay, so what we're going to end up trying to do is we're going to try to figure out an equation that starts with the find variable time. So we want something that goes t equals, and on the right side of the equation, I only want variables v sub I, v sub f, and because the acceleration due to gravity, I want a. Because in our equations, we don't have little g, we have a. Cool? So I want an equation that meets this criteria. So it starts with t, and on the right side, it only has v sub I, v sub f, and a. So if I look at all of my equations, this is where we can look at them. So it starts off with t equals. So what I'm going to do is I'm going to circle all the ones that start with t. So this one starts with t. There's no t's in this one. There's a t here. And there's a t equals here. So hopefully this makes sense. Apologize for the bird if you can hear that. So this needs to be in the front, and then I can only have v sub I, v sub f, and t, or a, sorry. V sub I, v sub f, and a. Now, the variable that's left over that I cannot have so I'm solving for t, so I don't know that. I do know the acceleration. I do know final velocity. I do know initial velocity, but I don't know anything about the displacement. I don't know what the max height is. So any equation that has d in the equation, I can immediately cancel that out. So if I look back at the one that we circled, this one has d, so this one's gone. This one has d, so that's gone. Now the only one that I have left circled will be this one here. So I'm going to write that on the other page. So we get t equals v sub f minus v sub I divided by a. Now just to make sure that this is indeed the correct equation, a way to double check is that on the left side, I have my find variable. Cool, I get a check mark. And then on the right side, I should only have these things. So v sub I, v sub f, and a, v sub f, v sub I, v sub a, or sorry, a. So this is indeed the correct equation. Now I'm going to continue on. And anywhere that I have a variable, I'm going to put open parentheses. So this would be where the v sub f was, right here. This is where the v sub I would be. And this is where a would be. Now at this point, I'm going to plug in the values. The value for v sub f was 0, because that is my velocity at the maximum height. My initial velocity was given to us as 14 meters per second. And then finally, my acceleration was the acceleration due to gravity, so that would be negative 10 meters per second squared. So what that gives us is negative 14, because 0 minus 14 is negative 14, divided by negative 10. And that gives us a positive 1.4 seconds for the time. Does that make sense? Does anybody have any questions? All right. And I'll do the other one that we have something going into the air. Okay. So, in this problem, it says if the ball was thrown straight into the air with a velocity of 33 meters per second, what is the maximum height? Okay, so in the last one, we were looking for the amount of time it took. In this time, or in this question, it's asking what is the maximum height? So when we're talking about maximum height with a vertical problem like this, the maximum height would be represented by displacement. And that's going to be in meters. All right, so we're trying to find the max height. So it's thrown straight into the air with a velocity of 33 meters per second. So if we're trying to figure out the max height, we know immediately we know that the final velocity is 0, but we're given in the problem numerically the initial velocity, which is 33 meters per second. We know the final velocity is 0 meters per second. And then, like I mentioned before, the acceleration due to gravity is negative 10 meters per second squared. And just to reiterate, this is the acceleration due to gravity. So this is going to represent our acceleration in the kinematic equations. So I want an equation that starts with displacement, and then it only contains v sub I, v sub f, and a. And the variable that I don't have any information about would be t. Okay, I don't know anything about t, so any equation that has t in it, I can immediately cancel out. So it starts with D, has V sub I, V sub F, and A. So let's start off with just circling all the ones that have D equals. D equals, D equals. There's no D equals in this one. And then D equals here. Now, we can immediately knock out any of the ones that have time. So this one has time here, so this one's gone. This one has time, so that one's gone. This is the only one that does not have time, and that's the only one that's left. Yes. So D equals V sub F squared minus V sub I squared divided by 2 times the acceleration. Yeah. Okay. So just to verify that this is indeed the right one before I even start plugging stuff in. So on the left side, my finds match. And on the right side, V sub F, V sub I, and A. V sub F, V sub I, and A. Cool. So this is indeed the right one. So anywhere that I've got variables, I'm going to put empty parentheses. All right, so this one here would be for the V sub F. This is V sub I. And then down here, this would be the acceleration. All right. So when I plug in the numbers, V sub I, it's going to be right here, so that's 33. V sub F at the max height is going to be 0. And then the acceleration due to gravity is -10. So what this ends up being is going to be a negative 33 squared, not cubed. And then this would be -20. So the negatives and then both of those negatives cancel out. So what I finally end up with is 33 squared divided by 20. And I get approximately 54.45. This would be meters. But then in the question, it says round to the nearest 1 decimal point. Okay. So the nearest 1 decimal point means that I'm going to have one value after the decimal point. So I want to round to this decimal here. So if I'm rounding to that accuracy, I have to look at the value to the right of it. So if this number is greater than or equal to 5, I round up. If it's less than 5, I round down. So this answer should be what? $54.5 meters. Man, it is pouring outside. Good Lord. Okay. Anybody have any questions? Can I get some feedback, guys? Okay, cool. So those problems dealing with like the vertical motion, that's gonna be the most difficult. The only reason it's the most difficult is because of the fact that the acceleration due to gravity, and I have little g equals -10, and the velocity at the max height being 0 meters per second, that is going to take a little bit more critical thinking. But the rest of the problems that I've given you, so like for number 15, like this. So how long would it take a car to go a distance of 574 meters if it was initially traveling at 15 meters per second and it was accelerating at 3 meters per second squared? I do the exact same process as the previous two questions. So I figure out, I read through the problem so I understand what's going on. I figure out what I need to find, like what the objective of the question is. I write down my knowns. Then I look through all of my equations and I figure out an equation that starts with my find variable and it only contains variables that have my known variables. It only contains my known variables on the right side. Then I verify to make sure that that is the correct equation, plug in the values, and then I get an answer. I do that for every single problem. Cool? Are we good with that? Okay. So, what I'm going to do. All right. So I'm going to leave it. I'm going to stop the live